Good evening, students.
Good evening, sir.
Last class, what we started, ma? The hydrocarbon, right? Am I right? I think these are the things we discussed, right, ma?
Sir, can you repeat? Sir?
Last class, we discussed about the hydrocarbon, right?
Yes, sir.
Today, what we have to discuss in that benzene also, directive effect, addition reaction, everything we completed. Last class, finally, what we discussed, ma? Say, you also forget, huh? Just a minute. Hydrocarbons. 11th January. This is the things we discussed, right? I think this is the things we have discussed finally, correct? Am I right? Yes or no? What is the next chapter we are having? Shall we do the problem in this unit?
Sir, yes, sir.
Any other topic we left? I think we have to start redox reaction, right? Shall we do the problem or we will start the redox reaction? Which one will do today?
We'll start with redox reaction.
Yes, ma'am. Please little louder.
We will start with redox reaction, sir.
Okay, we will start the redox reaction. Good. So what is the meaning of redox? If the reduction, oxidation occur simultaneously, then the reaction is called redox reaction. Okay. In case, what is reduction? What is oxidation? What is reduction? What is oxidation? What is reduction?
Sir, addition of hydrogen, removal of oxygen. Sir.
Addition of hydrogen, removal of oxygen. That is called reduction. So, redox reaction we are going to see. So, most of the chemical reactions which involve a transfer of electron from one compound to another compound or one substance to another substance. So, the transfer of electrons are termed as in terms of either it lost their oxidation number or it can increase their oxidation number or can decrease their oxidation number. Then we call it as that those type of reaction. If the oxidation number increases, then the oxidation. If the oxidation number decreases, then it is called reduction. So a number of phenomena, if you are taking like biological, industrial, metallurgical, and agriculture, all are concerned with the redox reaction. Whatever our biochemical reaction, which is also concerned with the redox reaction. When you are inhaling air there and then exhaling the air, so it involved also redox reaction because in the hemoglobin we have iron 3, whether in the low spin or high spin Fe2 or Fe3, based on that only that normal human being life is also going. So it also depends upon the redox reaction. So this reaction have large applications like burning of fuel, electrochemical processes, batteries, and then the environmental remedy issue, hydrogen economy, development of ozone hole, everything which involved with the redox reaction. So we can classify the concept, classical concept of oxidation and reduction reaction. So first, you should remember these two words, Leoger, loss of electron oxidation, gain of electron reduction. So loss of electron oxidation, gain of electron reduction. So according to this concept, when the oxidation is a process which involves addition of, when you are taking oxidation, you can tell anything, loss of electron oxidation, okay, or otherwise you can say addition of oxygen, or removal of hydrogen. So removal of hydrogen or electropositive element. Addition of oxygen or electronegative element. So I told you, you know that in the periodic table, fluorine is the most oxidizing agent because it can increase the oxidation number of all the elements. For example, if you are taking oxygen family, halogen family, it increase. So we know that SF6, IF7, like that. Okay. So the fluorine can increase all the oxidation. That's why we are saying when your addition of oxygen or otherwise addition of electronegative element, that also increase the oxidation number. That is also involved in the oxidation reaction. So this is called oxidation. For example, you can consider this reaction. SnCl2. When you are adding Cl2, it becomes SnCl4. So you know that how to say that oxidation number when you are writing mx4 like this metal atom. So what is the oxidation number? So this 4 goes to the superscript of your metal, and this subscript will go to the superscript of your non-metal. When you are taking, metal become 4 plus and 4x minus. This is that method. So by this way you can find out. Suppose M2O3 like this, if you are there, if it is there, then M become 3 plus, O become 2 minus, 3 2O minus. 2M3 plus, it become numbers of the metal, and also it will become superscript of your other element which is involved in the bonding. So that's you should remember. This is known as Frisch-Grass method. So by that way, when you are seeing here, the Sn having +2 oxidation state, whereas here Sn having which oxidation? Which oxidation, ma? Which oxidation? Which oxidation? Here Sn become +2. What is the oxidation state of here? The tin. Yes. Yes, tell me. So long by here tin will be 2 plus. Here tin will be, what is oxidation state? What is the oxidation state? Yeah, here SnCl4. Then what is the oxidation state of tin? What is the oxidation state of tin? What is the oxidation state of tin? What is the oxidation state of tin, ma? So are you attending a class? Tin will be Sn4 plus. So you take an example, metal X means, so you have, it will be number 1. This will be number 1. Then this will go to the oxidation state of your metal. This will go to the oxidation state of your non-metal. You know that the positive element only we are writing first. So one metal become +1 charge and one non-metal become -1 charge. The negative part always we are writing the next one. So always we will write the positive followed by the negative. Okay, this is the way to write the formula of the chemicals. So when you are coming to the concept of the oxidation, you take the example. When you take the magnesium plus oxygen, it become 2MgO. Sorry, MgO. When you are take the magnesium, it's a zero oxidation state. Okay. When you take that oxygen, the oxygen is bonded with one more oxygen. They are not in the difference of electronegativity. So the oxidation state is zero for the O2. Whereas when come here, it become become +1. That means so magnesium become Mg2 plus, oxygen become O2 minus. Okay, that's why you are taking 2 magnesium of oxygen. Okay, and then this is known as so the addition of oxygen. Look here, that 0 Mg0 become Mg2 plus, increased their oxidation state. That's why it is a oxidation. And then when you are taking hydrogen gas, hydrogen sulfide gas, when you are adding electronegative element chlorine to that, it becomes 2HCl and then sulfur. Here you are removing the hydrogen. So removal of hydrogen. Here the hydrogen become H plus 2H plus and S2 minus. Okay. When you are removing the H plus, it becomes sulfur. Okay, S0. So they increase in the oxidation state. So it increases -2 to -1, 0. That's why increase in the oxidation state. That's why it is called removal of hydrogen. Then it is called oxidation. And then addition of electronegative element. That is the example for the SN. Addition of electronegative element. Okay. And then removal of electropositive element. For example, you can take potassium iodide. Okay. And then chlorine. When you are treating, it gives 2 KCl plus I2. You take an example of Ki. K become Ki plus and then I minus. This is the electropositive element which you are removing by using the chlorine. So once if you are removing, it become I2 minus 0. So the removal of electropositive element, it also increases the oxidation number. Then it is also called as oxidation reaction. So this is the by which way you can say these are the oxidation. So whatever it's opposite to all those things, then it become reduction. So what is reduction? We'll see. So reduction is the according to the concept of classical concept. Reduction is a process which involve gain of electron reduction, and addition of hydrogen, or electropositive element, or removal of oxygen or electronegative element. So by this way, you can consider the reduction reaction. So we'll see how it will become a reduction. Okay, take an example. When you are having copper oxide plus carbon, here oxygen become 2 minus, O2 minus, and Cu2 plus. Okay, when you are say joining this, it will become copper 0 plus CO. So what happened when you are removing the oxygen from the copper metal? The 2 plus become 0. So the oxidation number decreases. So oxidation number decreases, it become reduction. இப்படி கூட சொல்லலாம். When the oxidation number increases, it becomes oxidation. So when you're taking copper plus carbon monoxide, it becomes copper 0. So this is called removal of oxygen. And then if you take the next example, when you are having bromine plus hydrogen gas, hydrogen sulfide, it gives hydrogen bromide plus sulfur. So when you are adding hydrogen, so it also causes reduction. Look here, Br2 becomes 0, that become H plus Br minus. So it decrease in the oxidation number. That's why it is called addition of hydrogen. It is also called reduction. And then one more example, you take copper chloride plus copper. Okay, it becomes cuprous chloride. Here Cu2 plus 2Cl minus and copper 0. Here Cu2 2 plus, then become Cu plus, and 2Cl become Cl minus, or otherwise 2CuCl. So when you are adding addition of electropositive element also increases their oxidation number. This is the way. And one more example, if you are looking, this mercury chloride 2Hg, so Hg2 plus 2Cl minus. Okay, when you are adding with tin chloride SnCl2, Sn2 plus and 2Cl minus. Okay, it gives Hg2 Cl2 plus SnCl4. So totally 4 halogen is there, 2 is there, 2 goes there. So what happened? Hg2 plus Cl2 minus. So how you can write? Hg plus Cl minus Sn4 plus and 4Cl minus. When you're looking plus minus. So Hg2 plus 2 Hg plus. So decrease in the oxidation number. That is why it is called reduction. This is example for removal of electronegative element. Okay, so these are the simplest example for the reduction oxidation. Now you should learn what is oxidizing agent. What is oxidizing agent? Oxidizing agent is a substance which provide oxygen or any other electronegative element, or removes hydrogen, or otherwise other electropositive element in the chemical reaction is known as oxidizing agent. So the oxidizing agents which cause the oxidation but it will reduce. The reagent which cause the oxidation but it get reduced. It will reduce, it get reduced. Then it is called oxidizing agent. So what is the reducing agent? So reducing agent is the opposite to oxidation. So reducing agent which cause the reduction reaction but it get oxidized. So what is the meaning? So the reducing agent which is a substance which provide hydrogen. So நீங்க என்னெல்லாம் சொன்னீங்களோ இதெல்லாம் ப்ரொவைட் பண்ணுச்சுன்னா அது வந்து reducing agent. So இங்க என்னெல்லாம் சொன்னீங்களோ அதை ப்ரொவைட் பண்ணுச்சுன்னா இது வந்து ஆக்சிடைசிங் ஏஜென்ட். ஓகே, பட் ஆக்சிடைசிங் ஏஜென்ட்டுக்கு என்ன ஆகும், ரெடியூசிங் ஏஜென்ட் என்ன ஆகும்னா Oxidizing agent வந்து reduce ஆகும், reducing agent வந்து oxidize ஆகும். அவ்வளவுதான். Okay. So now we'll go for what is redox reaction. Are able to understand? Are able to understand?
Yes,
Or
sir.
able? Okay. Redox reaction. So a redox reaction in terms of electron transfer we are going to see. So in terms of electron transfer, so we can say loss of electron oxidation, gain of electron reduction. So rende one oxidation, one reduction. If they are taking simultaneously, then it is called redox reaction. Okay. So we can say oxidation is defined as a process which involves loss of electron by an atom or ion. Okay, the loss of electron it result increase in the positive charge or decrease in the negative charge. So one more thing, what it increases positive charge or decreases negative charge. Okay, for example, when you take magnesium, it become Mg2 plus 2 electron, loss of electron oxidation. S2 minus become S plus 2 electron, so it is also loss of electron, but what happened, the negative charge increases the minus to 0, it is also reduction. Fe2 plus it goes to Fe3 plus electron, then it is called oxidation. So what is the reduction? Gain of electron is reduction. Gain of electron is reduction. So the reduction is defined as a process which involves gain of electron by atom or ion. So the gain of electron may result decreases positive charge and increases negative charge. Then it is called reduction. Okay. So for example, when you take MnO4 minus plus it take one more electron, it becomes MnO4 2 minus. When you take chlorine plus electron, 2 electrons, it becomes 2Cl minus. So when you have Hg2 plus 2 electrons, it becomes Hg plus. So Fe3 plus 1 electron, it becomes Fe2 plus. So all are called as, look here, decrease in the positive, minus, increase in the minus charge. So இங்க 0 இருக்கு, இங்க minus, increase ஆயிருக்கு. 2 plus 3 plus 2 plus. So decrease in the positive charge, increase in the negative charge, which cause the reduction. So according to the electron concept, oxidizing agent is a substance which accept the electron. Reducing agent is a substance which involve loss of electron during the redox reaction. So according to electronic concept, so oxidizing agent is a substance which accept electron. So reducing agent, which is a substance which involve loss of electrons. So during the redox reaction, oxidizing agent accept the electron, reducing agent loss of electron. So how you can write when you're writing reducing agent equilibrium with, so reducing agent become oxidizing agent plus electron. Then the reducing agent become oxidizing agent, so now that is known as oxidation. Oxidizing agent become reducing agent, so now it become reduction. I told you Oxidizing agent, it causes the oxidation, but it will get reduced. Same way, oxidizing agent which cause the oxidation, but it get reduced. Oxidation or reduction or reduction or oxidation. So competitive electron transfer reaction. When you are taking metal rod, zinc is placed in solution of copper nitrate. So we can observe that the zinc rod start dissolve with the reddish brown deposit. Same way, the blue color copper nitrate start fading and become colorless Sn2 plus ion. Become colorless. And the reaction is exothermic because the solution become very hot. The solution remain electrically neutral. So we can observe many things. Now what we are going to know is going to see is oxidation number. How to find out the oxidation number? Okay. So whatever we are recording here, you should keep in mind. So oxidation number which define the charge with the atom appear to possess when all other atoms are removed from its ion. Okay. Oxidation number of an atom can be 0, positive, negative, or a fraction. Anything it can be. Okay. For the same atom, oxidation number vary from compound to compound because of it differ their valency. For example, when you are taking D block element, their oxidation number can vary. For example, manganese. Same way, when you're taking iron, it will be exit Fe2 plus and Fe3 plus also. Okay. So, if the electrons are gained by atom in the form of compound, oxidation number is negative. If the electron is lost by an atom, the formation of compound is known as positive sign. If represent a real charge in the ionic compound, so imagine its charges. Okay. So when you are taking a neutral atom, if you are adding electron, then it become anion. Am I right? So what happened? So I'm taking A. When you're adding E minus, then it becomes A minus. So when you are writing a negative charge, it increase the. So when you are adding an electron, you are saying the oxidation number is negative charge. Suppose the same atom you are adding 2 electron, then it becomes A2 minus. So it increases in the negative charge. So same atom, it leaves 1 electron plus the atom become A plus positive charge. So if the atom lose their electron, it become positive charge. Then it is called cation, or you can write the oxidation number as positive. Suppose the same atom, if it is lose 2 electron, then it become A2 plus. Okay. So this you have to remember. And then the next one is valency. So valence is different from the valence electron. Valence electron means the number of electrons present in the lost shell. It's known as valence electron. So valence is the ability or capacity of an atom which can bind with the other atom is known as valency. So valency is the capacity of an element. Capacity of an element to combine with other element. Combine with other element is known as valency. Okay. So there is a rule for the assigning oxidation number. So what are the rules we have to say? Rules for assigning oxidation number. Rule number one, oxidation number of an elementary state. Okay, oxidation number of an element always 0. Okay, for example, N2, Cl2, H2, O2, P4, S8, zinc. So each element is 0. Okay, and then alkali metal shows +1 oxidation number. Okay, example, lithium, sodium, potassium, rubidium, cesium, francium. Generally, we will discuss up to cesium. We will leave the francium because it's a radioactive. And then alkali earth metal shows oxidation state. Beryllium, magnesium, calcium, strontium, barium. Okay, and then for the hydrogen, oxidation number is +1, except metal hydrides. For example, sodium hydride and magnesium hydride and calcium hydride. Because it is electropositive, then this it become Na plus H minus, Mg2 plus and 2H minus, Ca2 plus and 2H minus. Here the oxidation number is -1. Okay, wherever it will be differ, that we have to mention. And then so oxidation number of oxygen is always -2. Okay, except peroxide. Peroxide means hydrogen will combine with 2 oxygen. So OOHH. Okay, here and then sodium peroxide, barium oxide. So here the oxidation number is -1. Same way, superoxide. What is superoxide? It like KO2. Then K plus O2 minus or O2 minus and RbO2, O2 minus. Here the oxidation number is 1/2. Then OF2. Here the oxidation number is +2. And O2F2, because fluorine is more electronegative, so the oxidation number is +1. These are the things we have to remember. And then fluorine is more electronegative element, most electronegative element. And assign the oxidation number is -1. So other halogen, chlorine, bromine, iodine, also at the sometime it will become -1. Okay, except interhalogen compounds like IF5, ICl4, it will change. ClO2. Okay, that time it may vary. Okay, and then for the sulfur, in sulfide, oxidation number of sulfur is -2. So the oxidation number of an atom is same as its charges. Okay, Li plus ion means that is the oxidation. Al3 plus ion means plus 3 is the oxidation number. Okay, SO4 2 minus means the oxidation number become minus 2. PO4 3 minus means oxidation number become minus 3. So we can take it as like that. Okay. And then sum of oxidation number of all atoms in the neutral molecule is 0. Is 0. Same way, the oxidation number of metals in carbonyl is always 0. So metal carbonyl, for example, nickel tetracarbonyl, iron pentacarbonyl. So when you are taking nickel is 0, iron is 0. Okay. So now we will find out some of the element and then we will work it out for the oxidation number of how to find out the oxidation number. And then special, because next what we are going to see is balancing the redox reaction. That's very important. That's why. Okay. Because this unit is very smaller unit, but we should learn many concepts. Because this redox reaction, which is helpful in the electrochemistry and many inorganic chemistry. Okay. Please carefully learn this. Suppose if it is compound formed by union of two elements, more electronegative atom have the negative oxidation state, where the less electronegative element possesses the positive number, oxidation number. For example, nitrogen shows -3 in the NH3. For example, if you are taking NH3 and NF3, okay, here it will become -3 for the nitrogen oxidation status -3. Whereas when you are coming here, nitrogen will become +3 oxidation state because it's more electronegative than nitrogen. So the nitrogen will bear a positive charge. Here, nitrogen is more electronegative than hydrogen. That's why nitrogen bear a minus negative charge. Is it clear? So sometimes the same atom which also shows different oxidation state. For example, thiosulfate, sodium thiosulfate. The sodium thiosulfate Na2S2O3. So the oxidation state of two atoms, sulfur atom become different. How it will be? So when you are writing the structure of this sodium thiosulfate, NaOSO double bond O, ultimate bond S. This is the structure. According to that, and the one sulfur which will have the +6 oxidation state, another sulfur which will have the oxidation state of -2. Okay, so the sulfur can exhibit two different oxidations. These are the things you have to keep in mind. Now we'll find out NH3 BeCl2 BF3. Okay, so for the nitrogen we are going to find out beryllium and then boron we are going to find out. So X is the oxidation state of nitrogen, one nitrogen plus 3 hydrogen. 3 hydrogen becomes 3 plus 1 is equal to 0. So X plus 3 is equal to 0, X plus -3. So the oxidation state of the nitrogen is -2. When you're taking beryllium, X plus 2 into -1 because chlorine become -1, 0. So X2 minus becomes 0, X become +2. Oxidation state is +2. Then boron is X plus through fluorine atom is the -1 becomes 0, X minus 3 becomes 0, X equal to +3. So +3 is the oxidation state. And then when you are considering BH4 minus. We have to calculate the oxidation state for the boron. Okay. So when you are considering boron, so boron plus 4 into hydrogen or hydrate become -1, and then -1 becomes 0. Then boron -4 -1 becomes 0. Sorry, I made mistake. It become -1, it become -1, and boron become -1 plus 4. Then it become +3 is the oxidation state. AlH4 minus. When you are considering this aluminum, you have to find out plus 4 into -1 because hydrate become -1 and aluminum become -4 -1 and aluminum become +3. Okay, so same way. NaOH. You have to find out the oxidation state for oxygen. So sodium is +1, oxygen is 0. So you are going to find out. That's why you put X, and then hydrogen is 1. Okay, equal to 0. X plus 2 becomes 0. X equal to -2. And then KMnO4. What is that alkali metal? It becomes +1, and then manganese. 4 oxygen -2 becomes 0. So manganese become already 8 -8 plus 1 becomes 0, and manganese -7 0. Manganese become +7. MnSO4. MnSO4. You are going to find out manganese. So you are taken manganese, sulfur become -2, right? And then 4 into -2 becomes 0. Mn -2 -8. So actually this SO4 become -2. -2 is equal to 0, and then manganese become +2. And then K2MnO4. For this, 2 into 1 plus manganese plus 4 into -2 becomes 0. So 2 manganese -8 becomes 0. Manganese become -6 0. Manganese equal to +6. So look this, for the manganese you have +6 oxidation, +2 oxidation, +6. Same manganese you have MnCl4, MnO2. You are going to find out. So the manganese +4 -1 becomes 0. So manganese -4 becomes 0. Manganese become +4. Mn +2 into -2 becomes 0. Mn -4 becomes 0. Mn become +4. So we have +4 +7 +6 oxidation state. So like this, we can find out many oxidation state of the metal. Okay. For example, now you try for the calcium hydroxide and tell calcium hydroxide, copper oxide, copper nitrate, lead nitrate. Now you tell me the oxidation state of the metals. You work it out and tell me. You work it out and tell me, ma.
Yes, sir.
For the calcium, what is the answer? So did you find out? Did you find out, Mark? Over. Have you completed that? Very good job. Other than Mitra and Shyam, nobody is there. Huh? Okay, ma, we will meet in the next class.
Thank you, sir.